যাই হোক, প্রপারলি তোমরা দেখতে পাচ্ছ, শুনতে পাচ্ছ? সো উই হ্যাভ গন থ্রু আ রিগ্রেশন প্রবলেম, and after that we have the data was marks, internet usage and attendance. We want to predict the marks, how marks is being affected by internet usage and attendance, and most of the things we have gone for the f value, prop greater than f value, that is our model is significant, our r square, our adjusted r square, and our p value of all the coefficients, p value of all the coefficients, we have gone for that. Now the second step we have gone for predict E comma recede. So what was that predict E comma recede? It was basically the residual. Okay, it is basically the residual, actual minus estimated, the regression of the residual, actual minus estimated. So we go for predict E comma recede. Now we will just check whether the assumptions hold or not. The assumption, what was the assumption? The assumption was basically that our error term follows a normal distribution. Okay, our error term follows a normal distribution. For that, what kind of test we have suggested? Sarpio walk test and Sarpio Wilk test. This Sarpio Wilk test will help us to see that whether our residual or the error term is normally distributed or not. Okay, so we have written ASWILK Sarpio Wilk E. This is our test, Sarpio Wilk test. This test basically shows us whether our residual is basically normally distributed or not as per our assumption. We have an assumption in classical linear regression model, and what was that assumption? The assumption is that our residual is normally distributed with zero mean. Okay, so we go for that. And what was the null hypothesis? I have written it. What was the null hypothesis? What was the null hypothesis of Sarpio Wilk test? You guys have also written it, I think. I already
The U is normally distributed.
exactly. The null hypothesis is the error term is normally distributed. So we go for that, we check for that, and we just click enter. You can see the prop greater than z value, p value. What is the p value? Is it greater than 0.05 or it is less than 0.05? It is greater than 0.05 or it is less than 0.05? The p value
Greater than.
greater than 0.05. So what is our decision rule? If the p value is greater than 0.05, what we accept and what we reject? If it is greater than 0.05, what we accept and what we reject?
Sir, we accept null.
Exactly, we accept the null hypothesis. If the p-value, the rule of thumb is if the p-value is less than 0.05, so we reject the null hypothesis and accept the alternative hypothesis at 5% level of significance. But if the p-value is greater than 0.05, we accept the null hypothesis and reject the alternative hypothesis at 5% level of significance. So what we can say, that whether, what was the null hypothesis? The null hypothesis, our error term or the residual term is normally distributed. Our error term or the residual term is normally distributed. One, what we can see basically, we can see that the p value is greater than 0.05. So we can say that our error term is basically normally distributed. Fine. So up to this, there is any problem? This up to this Shapiro-Wilk test, Shapiro-Wilk W test. Okay. Have you guys any type of do you guys have any type of issue regarding this test or up to
No, sir.
this? Okay, fine. Now we will go for further regression diagnostics. To go for further regression diagnostics, go for statistics, go to linear models, go to regression diagnostics. And in this regression diagnostics, you can see there are many types of available options and you can diagnose it one by one. Okay, we will go for diagnosing it one by one. First, we will go for the specification test. Click on this specification test. Now clicking on the specification test, it will allow you for a lot of tests. The first test is, can you just see this? What is the first test? Test for, what is the first test? It is test for heteroscedasticity. It is test for heteroscedasticity. Now, what is our assumption regarding classical linear regression model? What is our assumption regarding classical linear regression model? What is our assumption? What kind of assumption do
The
we?
homoscedasticity.
Homoscedasticity, basically. What is homoscedasticity? We used to assume that expectation of ui square is equals to sigma square, means it is constant and it is homoscedastic. It is constant and it is homoscedastic. So basically we will go for this. So there are multiple types of test. Okay, for homoscedasticity there are heteroscedasticity there are multiple types of test. One of the most famous test is Goldfield quant test. One of the most famous test is Goldfield quant test, and also one more famous test is Bruce Pagan test. Bruce Pagan, okay, you can write it Goldfield quant, and another is Bruce Pagan. Okay, Brushpagan, Bruce Pagan test. So we will go for heteroscedasticity test. What is the null hypothesis and alternative hypothesis in heteroscedasticity test? It will automatically will appear in this window. So we just go for test for heteroscedasticity. We go for what kind of test you are performing? Bruce Pagan test. You can perform F statistics, you can perform other also, but one of the most important and famous test is Bruce Pagan test. You can see there is a Bruce Pagan test. So we will just click on OK. You can just see. So what is the null hypothesis? From the window you can see what is the null hypothesis. What is the null hypothesis? H0. What is null hypothesis? From the window you can see null hypothesis is constant variance. Can you see? The null hypothesis is constant variance. Then what should be the alternative hypothesis? Then what should be the alternative hypothesis? What should be the alternative hypothesis then? Not constant variance, not
Not
constant.
constant.
So what is the p value? What is the p value? What is the p value? You can see what is the p value. Is it greater than 0.05 or it is less than 0.05? What is the p value? It is greater than 0.05 or less than 0.05?
Greater than
Greater than.
Okay, then what should we accept? The alternative or the null?
Null.
Okay, then we should accept the null. Then we can see that our second assumption is fulfilled or not. The second assumption is fulfilled or not. What was the assumption? So it is being fulfilled. Okay, now the question is, this is a test for heteroscedasticity. Have anyone opened your mic, please? Okay, so what was our assumption? It is basically the constant variance. So it is basically the constant variance. So it is being fulfilled. Now there are many other ways to check whether heteroscedasticity is present or not. There are many other ways also to check whether heteroscedasticity is present or not. Okay, for that what we do, we basically go to statistics and we go to regression diagnostics, we go to specification test. Now another test is, there is another test. Okay, the test is Ramsey specification error for omitted variables. Okay, omitted variable means, suppose you are fitting a regression equation y equals to alpha plus beta 1 x1 plus beta 2 x2. Do you think there should be more other variables to explain y? Do you think? Do you think there should be more other variables to explain
Yes,
y?
sir.
Yes. Do
Yes,
you
sir. There
think?
can
Yes.
be.
There can be. Okay. But I am not sure. I am not sure that there may be also other variables as per my data, as per my data of marks, internet usage, and the class attendance. There should be many other variables for explaining y. So there should be beta 3x3, there should be beta 4x4 and many more, but I do not know, I am not actually sure about that. How can I be sure about that? I have a data and I am working with it. I do not know whether I should need a lot of data, I should need a more data, I should need a more sample size, or I should need more variables onto that. So there is a test. That test is basically Ramsey test. That test is basically known as Ramsey test for omitted variables. You can just go for this Ramsey test for omitted variables. Use right hand side variables in the test. Right hand side variables, do you think what is our right hand side variable? What is our right hand side variable?
Independent variable.
Exactly. The right hand side means, you can see this is the left hand side and this is the right hand side. So I will go for use right hand side of my test. I will click on OK. So you can see they are what is the null hypothesis? Read it out. What is the null hypothesis? Model has no omitted variables, means model has no variables that is left out. My model has no variables that is being left out, no omitted variables. And what is the p value? What is the p value?
Greater than
So
0.05.
what should I go for? The null hypothesis or
Null.
alternative the null
Null hypothesis.
hypothesis. So the model has no alternative omitted variables. It is being accepted or rejected? It is being accepted or rejected? Should I accept it or reject it from the p value?
Accept.
Reject.
Accept, because null hypothesis is accepted 0.05 এর ওপরে,
Yes, yes.
it is, so it is basically accepted. So I can clearly say it out that the model actually has no omitted variables. I can clearly say it out that the model actually has no omitted variables. So I do not have to take beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus beta 4 x4. I do not have to take all this. The model is perfect up to beta 2 x2. The model is perfect up to beta 2. So the model do not have some variables which is being omitted. The model do not have some variables which is being omitted. Okay, fine. Now I will go for multicollinearity. Already you have gone for multicollinearity. What is the problem of multicollinearity? Just read it out. What is the problem of multicollinearity? A quick revision. What is the problem of multicollinearity? What
Means
is
a
the,
definition.
yes, a short line definition, one line definition. What is the problem of multicollinearity? Anyone? What is the problem of multicollinearity? From this equation, what is the problem of multicollinearity?
The independent variables are correlated with each
Exactly,
other.
exactly. My independent variables are correlated among themselves. X1 and X2 are correlated among themselves. Among themselves. Okay. So what was my independent variable? What was my independent variable? It
Internet
was
use
intent.
and attendance.
Should it be correlated? Is there any chance of getting
No, sir.
correlated? Yes, because if I bunk classes and do not go for attendance and all that, I should use
Sir,
my mobile phone. Yes.
but স্টেটাতে তো ওইটা পজিটিভলি ছিল এন্ড এটা নেগেটিভলি ছিল।
Yes, correlated means it may be negatively correlated or positively correlated. Both of way can be go for. Positive, negative, both way correlation can take place. Positive correlation also can take place. Negative correlation also can take place. There is no such words that na correlation
ওকে
mani
স্যার।
positive hobe ba negative hobe. So there it can be positive also, it can be negative also. But my total point is that internet usage and attendance, are they correlated among themselves? So I have to go and check for that.
স্যার
Okay. So what I go for? What type of test I go for? It is basically VIF, variance inflation factor, VIF test. I go for, you can see here is a there is a line, variance inflation factors for the independent variable, VIF test. So I click on OK. I click on OK. So what is the value of mean VIF? And what is the rule of thumb? What is the value of mean VIF?
আমরা ওই ভিআইটা কোথা থেকে দেখলাম আরেকবার একটু
Okay,
দেখাবেন?
statistics. In the statistics tabs, go to linear models and related, regression diagnostic, specification test. You can see
ওকে স্যার।
variance inflation factor. Okay. So what is the rule of thumb for VIF? If it is greater than, mean VIF is greater than how much? If the mean VIF
Greater
is
than
greater,
5 হলে moderate problem of
exactly,
multicollinearity দেখা যায়।
and greater than 10, if it is greater than 10, then
The severe
exactly.
multicollinearity.
But what is the mean VIF in our case? It is basically exactly equals to 1. So is there any problem of multicollinearity in our data? The answer is no.
হুম।
The answer is no. So if it is, the rule of thumb is, if it is greater than 5, then moderate problem. If it is greater than 10, then it is severe problem. But in this, in our case, the mean VIF is exactly equals to 1. So what is the thing? The thing is that we have a, we do not have a problem of multicollinearity in our case. Okay. Okay. Now we should go for something interesting. Go to statistics, go to linear models, go to regression diagnostics. Now what I will do, I will create a variable plot for each and every suppose when you have run the regression, what was the relation of internet usage and marks as per the coefficient? What was the relation between internet? Positive. And what was the relation between attendance and marks?
Negative.
Negative. I will just show it through a graph. I will just see it through a graph and verify whether the scatter plots and the line. I will draw a scatter plot and a line to verify whether my coefficients which I have predicted, whether my coefficients which I have estimated, I estimated the right thing or have I estimated the wrong thing. So if my internet usage and marks are positively related, how should my scatter plot and the line should look like? Downward sloping or upward sloping?
Upward.
Very good. And if for case of attendance?
Downward.
Okay, just go and just check regression diagnostic. You can see added variable plot. I will click on it. Do you want for all the independent variables or only one independent variable? I want for both the independent variables. I want for both the independent variables. That is why I am clicking on all variables. I am not clicking on one independent variable. I am clicking on all the variables. Just click on OK. It will take some time to generate the graph. Just give me.
স্যার এটার ভিডিওটা পাবো তো?
Exactly. It is being recorded.
বিকজ স্যার আমি অনেকগুলো নোট করছি না তো ওই
No
জন্য স্যার
problem, no
বললাম।
problem, no problem. It is being recorded. So এখন you guys just listen carefully now. You do not have to note anything. Do not have to take a note of anything. Okay. We will give the whole video. Okay. Okay. Now see, as per your
হ্যাঁ স্যার,
coefficients,
এটা ডাউনওয়ার্ড আছে আর ওটা
do it matches? Both of you just see.
স্যার।
Matches or not? In case of internet
স্যার
usage, it was having a coefficient of, the coefficient is also given 1.39, and in case of attendance it was minus 0.731605. So in case of coefficient for marks it is being upward sloping, and for coefficient it for attendance it is being downward sloping. Do you get it? Both of
ইয়েস
you
স্যার।
get it? Okay. So this is a checking procedure, that whether I have fitted the good regression model or whether I have fitted a wrong regression model. Okay, this is a checking procedure. What you do basically, you go for a checking procedure. Okay, so I just cut it. Now there is another thing. The thing is that go to regression diagnostic. There is a option you can see, component plus residual plot. Component plus residual plot. What does it means? Component plus residual plot basically gives us the whether I have written the equation. What is the my equation? Alpha plus beta 1 x1 plus beta 2 x2. My equation can be like this. My equation can be like this: y equals to alpha plus beta 1 x1 plus beta 2 x1 square plus beta 3 x2. Can be like this or not? It can be like this. I do not know. I have gone for a regression. This is a software. I have given the data. It has given me some types of analysis and I have estimated. But it may be that the square term of a particular variable, it should also be taken in my regression. It may happen. No. It may happen that I should add a square term to my regression model. There may be some linkage. There may be some linkage by adding the square term with my regression model. There may be some linkage. So for that, what we do, we go for the component plus residual plot. For that, we go for the component plus residual plot. Okay, in this component plus residual plot, in the independent variable, I should check for which one? You guys suggest me, for the internet usage or the attendance? What do you think? Square means the square of internet usage, means higher internet usage. Attendance means the higher attendance. Which I should check for? You guys suggest me. I should check for internet usage or attendance that is affecting marks. Internet usage square or attendance square? Which should affect more? Do you think, as from a layman's view, what should be the square term I should be adding, or should I check for?
Attending.
Yes, it may be. It may happen that higher attendance, the pupil who are getting more and more attendance, Suppose you are getting 5 attendance, Aporna is getting 5 attendance. When I am squaring it, attendance square, Shayok is getting 25 attendance. So that means that from Aporna to Shayok, if the attendance increases, means if the attendance increases in a square term, means more and more attendance, whether it is affecting my marks or affecting my marks more than that, or if Sushmita's attendance is more than us, then whether it is affecting marks highly. So should I check for that? So I go for attendance. So this means we are checking for the linearity. Linearity, have you studied Gauss Markov theorem? Have you studied, any one of you have studied Gauss Markov theorem? Blue properties, have you studied based linear unbiased estimator, blue properties? Any one of you, Aparna and Sushmita, Gauss Markov theorem, have you studied? So
Yes, sir.
if you have studied Gauss Markov theorem, what is the line of Gauss Markov theorem? Based linear unbiased estimator, it is written as blue. So what does it mean? L stands for linear. L stands for linear. So another thing we have to check for, that whether y. So you can see from this equation, see this equation. Can you tell me what is the relation between this beta 1 and y1, beta 1 and y? So if I do not add the square term, what is the relation is? What kind of relation it is? Linear relation, because at the in power of x, what is the power of x? What is the power of x1 in this case? What is the power of x1? It is basically 1. So it is sharing a linear relation. But when I am squaring x1, x1 square, what kind of relation is this? Is it a linear relation? Is it a linear relation? Is it sharing a linear relation with y? No. Is it not? It is not sharing linear relation with y. So one of the most important thing when we study Gauss Markov theorem, blue properties, base linear unbiased estimator. So this L stands for linear. So we have to prove, show that whether the linearity exists with y or not. Whether the linearity exists with y or not. If linearity exists, we can see from the data. If linearity do not exist, that we also can see from the data. Okay, have you got, do you got that? Is it clear, or should I repeat that linearity and square term? Is it clear to you guys?
ইয়েস স্যার, বাট এটা এখন আমার স্টার্ট হয়নি তো, তাই
No, no
স্যার
problem.
একটু।
You just see from a layman's view. You do not have to understand this blue. You just tell me that when x1 is only kept, what is the power of x1? It is 1. So what is the relation between y and x1? If I write a equation y equals to a plus bx, if I ask you from a layman's view that what is the relation between x and y, can you say? Linear relation. If I square it, bx square, what kind of relation? What kind of relation? Then it is a square type of relation, polynomial relation, or any kind of other relation. So I should always check for the linear relation. I should always check for the linearity, that whether it is linear or whether it is not linear. Okay, so I go for it.
ওকে স্যার।
I go for it. Now how to understand, that is very important. How to understand? So you have told me, you guys told me that to check for attendance. I just click on OK. See, I just click on OK. So you can see, exist linearity or not? Exist linearity or not? Yes, there
হ্যাঁ
exists
স্যার, লিনিয়ারিটি আছে।
linearity ache, means the scatter plots are totally downward sloping. How to understand that linearity is not present? If linearity was not present, your scatter plot will look like a U shape. A U shape. Your
ইয়েস স্যার।
linearity, it will look like a U shape. The scatter plots will come from here, it will end here, and it will go up to there. So how to understand linearity is not there? It will look like, the scatter plots will look like, just see, the scatter plots will look like, the scatter plots will look like this, means it will look like a U shape. It will look like a U shape. Then you can understand that there is no linearity. There is no linearity. So with attendance, linearity is there or not? Yes, there is linearity with
ইয়েস
attendance.
স্যার।
Okay, fine. So now we will go for statistics. We go for regression diagnostics. Now we will go for these residual versus fitted plot. Residual versus fitted plot will help us. The heteroscedasticity you checked for, E-stat head test, Bruce-Pagan test. This will allow us to see that from diagram that heteroscedasticity is present or not. First, remember the rule of thumb. If your scatter plot is scattered in such a way that there is no curve like or U like pattern, I am repeating, if your scatter plot, when you generate residual versus fitted plot, you go to check for heteroscedasticity problem. If your residual plot or the scatter plot looks like a U shape, looks like U shape, or it looks like a curvature shape, then it is basically known as there is a problem of heteroscedasticity. And if your scatter plot is scattered in such a way you are not getting any kind of shape, your scatter plot is scattered in such a way that you are not getting any kind of way, then what is your conclusion? There is no problem of heteroscedasticity. Again, I am repeating, if your residual versus fitted plot have a particular curvature or U-shaped scatter plot, then you will conclude that my data has a problem of heteroscedasticity. But if your residual versus fitted plot do not have any kind of the scatter plot do not looks like any kind of curvature, do not show any kind of curvature, no U shape, anything, then you should conclude what? You should conclude that it do not have a problem of heteroscedasticity. Now let's go to check. So what we'll see, that graph a residual plot after regress or ANOVA. Click OK to submit the graph. I'm just clicking on OK. Now tell me, from what do you conclude? What do you conclude? Is there any problem of heteroscedasticity or not?
So this is not linear.
No, I told that if there is a U shape or curvature, then you go for heteroscedasticity. And if there is no shape like that, U or curvature, you conclude that there is no problem of heteroscedasticity. Now conclude from this diagram. You do not have to check for linear. I do not told that to check for linear, polynomial, or etc etc. There are two things I have told.
heteroscedasticity নেই এখানে।
Exactly. The two things you have to check from the scatter plot. I have repeated several times, I am repeating again. You have to check whether there exists a curvature or U shape. Can you see, do it represents a curvature or U shape, the scatter plots? Do it
No, no.
represents? No. Then what should I conclude for? It has no shape. What should I conclude for? No problem of heteroscedasticity. No problem of heteroscedasticity. Okay. You can also go for their linear models and related election diagnostics. Residuals versus predictor plot. Can you say what are my predictors? Which are my predictors in this regression equation? Whom I am predicting? Can you say whom I am predicting? Whom I am predicting from the data? I am predicting internet usage, marks, or attendance. Whom I am predicting? Whom I am predicting?
Attendance.
Huh?
marks,
Exactly. Dependent variable is my marks. I am predicting marks. And who are my predictors?
internet
Internet
usage
users and attendance.
Internet usage and attendance. So I should go to check whether my residual values, which are my residual values? The E, the error term, actual minus estimated. Yes or no? Whether my residual values and my predictor means my internet usage and marks, do they have a relationship? Do they have a relationship? Means, do I have written yi hat equals to alpha hat plus beta 1 hat x1 plus beta 2 hat x2. I will go to check, and what is my error term? E. Error term is E. So what does it mean? Covariance of E comma x1. What does it mean? Can you tell me? Covariance, what does covariance means? Covariance means what? Correlation. Covariance means correlation. Do there any relation exist between my error term and the x1? Covariance of E comma x2. What was my x1? What was my x1? Internet usage. and what was my x2? Attendance. So do there any relation between error term and the x1 means the internet usage, or do there any relation between the error term and marks? I have to go to check, and I have to go and check that. Okay, I just go statistics, linear models and related, residual versus predictor plot. Which independent variable should I check for? I check for internet usage. I click on OK. See whether there is any relation between residual and internet usage, the error term and the internet usage. Can you see? Can you say that there is a linear relation, there is a polynomial relation, anything, etc., etc.?
No, sir.
Why? Why?
Because sir, there is no straight line or U-shaped
Exactly.
method.
Very good. Exactly. There is, the scatter plots are totally scattered in such a way that there exists no relation between the residuals. Are you getting what is the residual? Do you guys getting that what is the residual? I have predicted the
Yes, sir.
residual. Residual means actual minus estimated. So I have created there are two columns, actual column, estimated column. After subtracting each and every one, I am getting the residual. I am going to check whether there are any relation between the residual and the internet usage or not. So do you have any kind of residual and internet usage linkage from this
No,
data?
no,
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 sir.
no. There means my data is, my regression is okay. If there exists relation, then you have to go for another types of diagnostics and all that. Now I'll go to check which I have checked for. I have already checked for internet. I will go check attendance. Residual and attendance, it is being related or not? It is being related
No,
or not?
no, sir. This also not.
No? Okay. So there is no relation between the residuals and the attendance also. In the residuals and the attendance also. Fine. Okay. Now the last one. The last diagnostics I will go for. DFBETAS. This is a very advanced analysis. Okay. But I am telling you a little bit. First, let me see the data. Is there a particular data internet usage for a particular marks? Yes or no? For a particular internet usage for a particular marks? Yes or no? Yes or no? For a particular internet usage a particular marks?
Yes, sir.
Yes. I will go to check whether each and every internet usage values, suppose 45, 33, 27, 40, which values are actually, which observation, so these are known as observations, yes or no? This 45,
Yes,
33, 27, 40, these are observations, yes or no? Observations, each and every observations. I am going to check which observations are highly affecting my marks. Which observations are highly affecting my marks? Which observations are highly affecting my marks? For that, we do some advanced kind of analysis, and that is known as basically the DFBTA. Okay, DFBTA. So I will go with that. Statistics. I will go to that. What was that? DFBTS. For which should I check? For which independent variable? You guys suggest me. It attendance or internet usage?
attendance.
Yes. For attendance or internet usage? Which should I go for?
For attendance.
Okay, attendance. I am going for attendance. I click on OK. So there is a rule of thumb. You can just write it in your copy. You can just write it in your copy. What the DFBTA does, it actually have a value. What kind of value? That value is 2 by root n. You just write 2 by root n. 2 by root n. 2 by root n. Okay. Now
Sir, please can you repeat?
2 by root n. The threshold value is 2 by root n. I am going to the data. I will just explain. First, right? The threshold value is 2 by root n. Fine. Now, if how should I interpret it? How what should be my then root n? What is n here? Can you say what is n here? What is n here? What is n here? N means what?
Number of observations.
Exactly. Then what should be my 2 by root n value? Just calculate. 2 by root n. 2 by root n. What should be my value? 2 by root 100, because 100 observations were there. Yes or no?
Yes, sir.
100 observations were there. So if there are 100 observations,
2 by 50.
then no, root over 100 is 10. 2 by 10.
Oh, sorry.
2 by 10. Fine. Now
0.2.
it is 0.2. So how to interpret it? If any value, if any value is greater than 0.2, it is affecting, highly important for my analysis. And if it is less than 0.2, it is not such important for my analysis. Now how should I get the value? Where should I get the value? I will go to data, and I will go to, you have seen df beta attendance, a column have been created, df beta attendance. I will go to data, data editor, go to data editor. Is it greater than 0.2? 0.2? Yes, it is greater than the first one. Is it greater than
Yes, sir.
0.2?
Yes.
Sure, 0.2, it is 0.07.
না কম তো না
0.2 এর থেকে ছোট, it is less than 0.2, so it is not,
সরি স্যার, আমি ভেবেছি
হ্যাঁ,
জিরো পয়েন্ট
0.7. Okay,
সেভেন
no
হ্যাঁ
issues, no
আমি
issues, no
পয়েন্ট।
issues, no problem. তাহলে it is less than 0.2. Is it greater than 0.2? 0.25? Yes, it is greater than 0.2. So it is important for my analysis. This is important for predicting the marks. So a column have been created, and with the help of this column, it is greater than 0.2, 0.312. Yes, it is greater than 0.2. So it is this
Yes, sir.
observation, this 32 observation is also important for my predicting marks. Is it 0.02, though this is also not, 0.12, this is also not. So Stata have generated a column that is known as df beta, and with the help of this we can see that if it is greater than the threshold value is always 2 by root n, it is always calculated by 2 by root n. So if it is greater than that threshold value, we always go for that. Okay, it is important for my analysis on all that, important affecting the marks. But you have to do not have to understand this df beta, because these are very advanced level thing. Okay, very advanced level, so you do not have to. The most important thing then what we have to check for, just repeat with myself. First you have to check for what? Very fast, after running a regression, what you should check for at very first? Normality of residuals. Very good. Then for what? Heteroscedasticity.
heteroscedasticity,
Very good. Then
omitted variables,
okay, then
multicollinearity test.
very good. Then
Then we check for the blue property if it
okay,
holds or not.
linearity and all that. Then I should check for the residual versus fitted plot. Residual versus fitted plot. And finally I have to check for the residual versus predictor plot. Means whether there exists any kind of relation between the predictor, means attendance or internet usage, with the residual or not. Clear? All clear? Do you have any kind of question? All clear for you guys? See, if you
Yes,
have
sir.
any kind of question, just tell me. Do you guys have any kind of question? Just tell me. Aparna and Sushmita, any kind of question regarding Stata, this part?
মাল্টিকোলিয়ারিটি থাকলে
হুম হুম
ডেটার মধ্যে সেটা
হুম
কি আমরা গ্রাফ থেকে কোনোভাবে বুঝতে
নো নো
পারবো?
নো 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 কোনোভাবেই না।
ওটা শুধু ভিআইএফ থেকেই বোঝা
একদম
যাচ্ছে।
একদম ভিআইএফ
ঠিক আছে স্যার।
ভিআইএফ। Okay, for Aparna, any questions for Aparna?
No, sir.
No? Okay, fine. So this was the session. Thank you again to both of you for looking after me and joining the class again. Basically, I was having some kind of network issues. Okay, and when you just